Yes, welcome you all for another beautiful presentation on linear integrated circuits and applications. In brief, this is also called as LICA, linear integrated circuits and application, or sometimes also called as analog integrated circuits and applications. Okay, and most of the time this particular topic, linear integrated circuits and applications, starts with one of the brilliant amplifier that is called as operational amplifier. What is operational amplifier? This is very operational amplifier. In general, in short, this is can be written as op amp, right? Op amp, operational amplifier, or in general, in short, can be denoted with or can be written as op amp, operational amplifier. What is an operational amplifier? Operational amplifier is an is an integrated circuit. It is integrated circuit basically. Okay, and if you see the physical representation of an operational amplifier, that looks like this. I will show you the physical representation and then I will explain you about. So it has two input terminals basically. These are two input terminals and it has one output terminal, right? So this is terminal 1, this is terminal 2, these two are input terminals, and this is terminal 3, this is output terminal, and it has plus supply voltage plus VCC, you can say, and also it has minus VCC, or sometimes can be written as VEE or VCC, nothing wrong in that. This is the physical representation of an operational amplifier. So these two are called input terminals, right? These are called input terminals, right? And this third terminal is called as output terminal. This is called output terminal. Okay, and remember that what this amplifier will do. So this amplifier will amplifies the weak signal. Okay, so this operational amplifier will amplifies the small signal. That is one important parameter of this operational amplifier, and then most of the time this will takes the difference signal or the difference between the input signals. As we are able to see here, this is terminal 1, this is one of the one input terminal, the second is the another input terminal. So first input terminal is given to the minus sign, as well as the second input terminal is given to plus sign, means that so you can give the input to this negative terminal, as well as you can feed another input terminal to the positive sign, right? So depending on the inputs, we apply these two terminals, right? So it can be called as this particular terminal, terminal 1 is called as inverting terminal. Remember that this is called as inverting terminal. I can explain here. So this minus sign means the terminal 1, this is called inverting. This is called inverting terminal, and the plus sign, this particular terminal 2 is called as non-inverting. This is called non-inverting terminal. Non-inverting terminal means that what is the meaning of this? This means that if you apply the input to this inverting terminal, then your output is inverted form to the input actually. So your output is inverted form of the input signal, whereas for this non-inverting, so there is no inversion, right? So this is what the inverting and then non-inverting. So if you apply the input to the inverting terminal, in that case the plus terminal, all the non-inverting terminal will be kept at ground, then in that case it is called as inverting amplifier. If the input is given to the minus terminal, remember that. So if the input is given to the inverting terminal, means that if your input is given to this, let us say this is my Vi I am giving here. So in this case your plus sign must be grounded, So V suffix I is input. So you are applying your input here, inverting terminal. In this case, this particular op amp is called as inverting amplifier. This is called inverting amplifier, right? Inverting amplifier. And similarly, if the input is applied to the non-inverting terminal, this particular terminal, plus terminal, in that case your minus terminal must be grounded, right? So if the input is applied to this plus sign, it is non-inverting terminal, then it is called non-inverting amplifier. That is called non-inverting amplifier, right? Non-inverting amplifier. So these are the two important, very important classifications of an operational amplifier. One is the inverting amplifier and the second one is the non-inverting amplifier, right? Depending on the these signs allotted to these two input terminals. Now coming to the another important parameter or the characteristics, if we see, let us see some of the important characteristics of this amplifier. See that here, assume that, so this amplifier itself, basically this amplifier itself has some gain that is called as open loop gain or amplifier gain A, and this gain is very high actually. For this operational amplifier, the open loop gain A is very high. And also it does not allow any current to pass through this op amp, right? It does not allow any current to pass through this. Means that in this terminal, let us say here, let us say I1 is equal to 0 here, means the current flowing through this terminal is 0, right? Similarly, in this terminal also, the current, let us say I2, means the second terminal, I suffix 2 equal to 0. So in the first terminal, the current flowing through this is I suffix 1, means I1 equal to 0, as well as assume that in the second terminal also the current is 0, means that at input side, what is the current? It is 0. So if the current is 0, according to the Ohm's law, what is our Ohm's law? V is equal to I into R, right? This implies what is R? R is equal to V by I. Then what is I actually? You can take either a terminal 1 or at a terminal 2. In either case, if you take, the current is 0, therefore V by 0, something by 0 is equal to infinite. Means what is this? R is equal to infinite. What is R actually? R is nothing but your input impedance. That R will be considered at input stage of the amplifier. This is R suffix I actually, means R suffix input, right? Therefore R input is actually infinite. That is one of the very important ideal characteristic of an amplifier, operational amplifier. So for an operational amplifier, the input impedance is high. Ideally, that value is infinite. So the loop gain is infinite. That is first parameter. The loop gain is infinite, and the input impedance is also infinite. And now the output impedance is nothing but this is measured at the terminal 2. Let us say this is V0 with respect to some ground actually, you can say. This is my V0 here. So at this output stage, so I can measure my output impedance R naught, and the R naught is very low actually. The R naught is very low. The R naught is low. It is low actually. Ideally speaking, R naught is 0, 0 ohms. This is ideal value. R naught is 0 ohms. This is ideal value. Therefore, input impedance is infinite, output impedance is 0, and my gain is infinite. My gain is infinite. And then there is another parameter, the bandwidth. Okay, bandwidth. So the bandwidth of the operational amplifier is also infinite. The bandwidth is also infinite, right? The bandwidth is also infinite. So these are the some of the very important ideal characteristics of an operational amplifier. I think this is what I need to give in introduction, presentation regarding this operational amplifier, right? And moreover, this operational amplifier will performs certain operations, operations. Other than the amplification, it provides some logarithmic operations, and this operation amplifier can perform the mathematical operations such as addition, subtraction, and then integration, and then differentiation. So these mathematical operations can be performed by this operational amplifier, and also it can perform the logarithmic operations also, right? So these things we can see in detail in the coming presentations. I hope you understood this, and request you all to give your valuable comments and then feedbacks and your observations, and do not forget to share this valuable information to your colleagues and then friends, so that everybody should benefited out of this presentation, right? So with this I will finish off today's presentation, and will meet you in the next subsequent presentation. Have a good day.